Welcome to our exploration of motion, a fundamental concept in physics that describes how objects move from one place to another. Motion is all around us, from a car driving down the street to the planets orbiting the sun. In this chapter, we'll break down what motion really means, how we describe it, and why it's so important in understanding the world. We'll cover key terms, real-life examples, and the science behind how things move. By the end, you'll have a solid grasp of motion and its many forms. Let's start our journey into the fascinating world of movement. Motion, in simple terms, is the change in position of an object with respect to time. To describe motion, we need to know where an object starts, where it ends, and how long it takes to get there. Scientists use reference points to determine if something is moving. For example, if you're sitting in a train and see trees passing by, you know the train is in motion relative to the ground. Understanding motion helps us predict and explain the behavior of objects, whether it's a thrown ball or a satellite in orbit. Talking about motion, two important terms come up: distance and displacement. Distance is the total path covered by an object regardless of direction. Displacement, on the other hand, is the shortest straight-line distance from the starting point to the ending point along with the direction. For example, if you walk in a circle and end up where you started, your distance is the length of the circle, but your displacement is zero. This distinction helps us better describe how and where objects move. Speed tells us how fast an object is moving. It's calculated by dividing the distance traveled by the time taken. For example, if a car travels 100 kilometers in 2 hours, its speed is 50 kilometers per hour. Speed is a scalar quantity, meaning it only has magnitude and no direction. It helps us compare how quickly different objects move, whether it's a runner on a track or a plane in the sky. Knowing speed is essential for planning travel and understanding motion in everyday life. Velocity is similar to speed, but with one key difference: it includes direction. Velocity is a vector quantity, meaning it has both magnitude and direction. For example, if a car moves east at 60 kilometers per hour, its velocity is 60 km/h east. If it turns around and moves west at the same speed, its velocity changes. Velocity helps us understand not just how fast something moves, but also where it's going. This makes it a crucial concept in physics. Acceleration measures how quickly an object's velocity changes over time. If a car speeds up, slows down, or changes direction, it's accelerating. Acceleration is calculated by dividing the change in velocity by the time taken for that change. It's a vector quantity, so direction matters. For example, a roller coaster accelerates as it goes down a hill and decelerates as it climbs. Understanding acceleration helps us analyze everything from sports to space travel. Motion can be classified as uniform or non-uniform. In uniform motion, an object moves at a constant speed in a straight line, covering equal distances in equal intervals of time. Non-uniform motion means the speed or direction changes, so the object covers unequal distances in equal time intervals. For example, a car cruising steadily on a highway shows uniform motion, while a car in city traffic with frequent stops and turns shows non-uniform motion. Recognizing the type of motion helps us predict and analyze movement. Distance time graph is a useful tool for visualizing motion. On this graph, distance is plotted on the vertical axis and time on the horizontal axis. A straight slope line means constant speed, while a curved line shows changing speed. The steeper the line, the faster the object is moving. These graphs help us quickly understand how an object's position changes over time and can reveal patterns in motion, such as acceleration or rest periods. Relative motion describes how the movement of one object appears from the perspective of another. For example, if you're sitting in a moving train and another train passes by, it may seem like the other train is moving faster or slower depending on your own speed. This concept is important because motion is always measured relative to a chosen reference point. Understanding relative motion helps us make sense of everyday experiences, like driving or walking in a crowd. Inertia is a property of matter that resists changes in motion. According to Newton's first law, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This explains why you feel a jolt when a car suddenly stops or starts. Inertia depends on mass. The greater the mass, the greater the inertia. This principle is fundamental in understanding why objects behave the way they do when forces are applied. Circular motion occurs when an object moves along a circular path. Examples include a spinning wheel, a planet orbiting the sun, or a child on a merry-go-round. In circular motion, the direction of movement constantly changes, even if the speed remains the same. This means the object is always accelerating, because velocity includes direction. Understanding circular motion helps us analyze everything from amusement park rides to the orbits of celestial bodies. Linear velocity refers to the rate at which an object moves along a straight path, while angular velocity describes how quickly an object rotates around a central point. For example, a car driving down a road has linear velocity, while a spinning top has angular velocity. Both concepts are important in physics, as they help us understand different types of motion and how forces act on objects in various situations. Centripetal force is the force that keeps an object moving in a circular path. It always acts towards the center of the circle. For example, when you swing a ball on a string, the tension in the string provides the centripetal force. Without this force, the object would move in a straight line instead of a circle. Centripetal force is essential for understanding the motion of planets, satellites, and even cars turning around a curve. Projectile motion describes the curved path an object follows when it is thrown or launched into the air. The motion is influenced by two forces: gravity, which pulls the object downward, and the initial force that propels it forward. Examples include a basketball shot, a cannonball, or a football kick. Understanding projectile motion helps us predict where objects will land and how to aim or launch them accurately. Freefall occurs when an object moves under the influence of gravity alone, with no other forces acting on it. For example, when you drop a ball, it accelerates downward due to gravity. In a vacuum where there's no air resistance, all objects fall at the same rate regardless of their mass. Free fall helps us understand how gravity works and why objects behave the way they do when dropped. Gravity is a force that attracts objects toward each other. On Earth, gravity pulls everything toward the ground, giving weight to objects and causing things to fall when dropped. Gravity not only affects free fall but also keeps planets in orbit and influences tides. It's a fundamental force that shapes the motion of everything from apples to asteroids. Understanding gravity helps us explain a wide range of natural phenomena. Pendulum is a weight suspended from a fixed point so it can swing freely back and forth. The motion of a pendulum is an example of periodic motion, where the movement repeats in a regular cycle. Gravity pulls the pendulum down while inertia keeps it moving. Pendulums are used in clocks, scientific experiments, and amusement park rides. Studying pendulums helps us understand the principles of motion and timekeeping. Principle of conservation of momentum states that the total momentum of a closed system remains constant unless acted upon by an external force. Momentum is the product of an object's mass and velocity. For example, when two ice skaters push off each other, their combined momentum before and after the push remains the same. This principle is key in understanding collisions and interactions in physics. Pulse is the change in momentum of an object when a force is applied over a short period of time. It's calculated by multiplying the force by the time during which it acts. For example, when you hit a tennis ball with a racket, the force applied in a brief moment changes the ball's momentum. Impulse helps us understand how forces cause objects to start, stop, or change direction quickly. Any factors can influence the motion of an object. These include the object's mass, the forces acting on it, friction, air resistance, and even the surface it moves on. For example, a heavier object requires more force to move, and a rough surface increases friction, slowing things down. Understanding these factors helps us predict how objects will move in different situations, from sports to engineering. Friction is a force that opposes motion between two surfaces in contact. It can slow down or stop moving objects, like a car braking or a ball rolling to a stop. While friction can be a hindrance, it's also useful. It allows us to walk without slipping and cars to grip the road. The amount of friction depends on the surfaces and the force pressing them together. Managing friction is important in everything from sports to machinery. There are several types of friction: static, sliding, rolling, and fluid. Static friction keeps an object at rest. Sliding friction acts when objects slide past each other. Rolling friction occurs with wheels or balls, and fluid friction happens in liquids or gases. Each type plays a role in how objects move and interact. For example, rolling friction makes it easier to move heavy furniture on wheels than dragging it across the floor. Air resistance is a type of friction that acts against objects moving through the air. It slows down falling objects and affects everything from skydivers to airplanes. The faster an object moves, the greater the air resistance. Streamlined shapes help reduce air resistance, allowing objects to move more efficiently. Understanding air resistance is important in designing vehicles, sports equipment, and even clothing for athletes. Newton's laws of motion are three fundamental principles that describe how objects move. The first law is inertia, the second law relates force, mass, and acceleration, and the third law states that every action has an equal and opposite reaction. These laws form the foundation of classical mechanics and help us understand everything from launching rockets to riding a bicycle. Mastering these laws is key to understanding motion in the physical world. Force is any push or pull that can cause an object to move, stop, or change direction. The relationship between force and motion is central to physics. When a force acts on an object, it can accelerate, decelerate, or change direction depending on the magnitude and direction of the force. Everyday examples include pushing a shopping cart, kicking a ball, or pulling a sled. Understanding force helps us control and predict motion in countless situations. Mass of an object affects how it responds to forces. According to Newton's second law, acceleration depends on both the force applied and the object's mass. A heavier object requires more force to accelerate than a lighter one. This is why it's harder to push a loaded cart than an empty one. Understanding the relationship between mass and acceleration helps us design vehicles, machinery, and even athletic training programs. Momentum plays a crucial role in collisions. When two objects collide, their total momentum before and after the collision remains the same, provided no external force acts on them. This is the principle of conservation of momentum. For example, in a game of pool, the momentum of the cue ball is transferred to the other balls. Understanding momentum helps us analyze car crashes, sports, and even particle physics. Energy is closely linked to motion. Kinetic energy is the energy of movement, while potential energy is stored energy due to position. When an object moves, its kinetic energy increases. For example, a moving car has more kinetic energy than a parked one. Energy can be transformed from one form to another, such as when a ball rolls down a hill, converting potential energy into kinetic energy. Understanding energy helps us explain why objects move and how work is done. Work is done when a force moves an object over a distance. Power measures how quickly work is done. For example, lifting a box onto a shelf requires work, and doing it quickly means more power. Both concepts are important in understanding machines, engines, and even our own bodies. Work and power help us measure the effectiveness of different actions and devices in moving objects. Summary: motion is a complex but fascinating topic that touches every aspect of our lives. From understanding how cars move to predicting the paths of planets, the principles of motion help us make sense of the world. By mastering concepts like speed, velocity, acceleration, and force, we can analyze and predict movement in countless situations. These ideas are not just theoretical, they have practical applications in engineering, sports, transportation, and beyond. Keep exploring and you'll discover even more ways motion shapes our universe.